Saxon Algebra 1, lesson 45, which is exciting because that means, look, we're on our last week of new lessons before Christmas. We are going to squeeze a little midterm in there, but still we're almost to our completion point we're done with 2021, right? That's exciting. So we'll have one more review problem this week. We'll have one more check-in as usual, and then we'll be into our midterm week. It'll work just like midterms in the past. On Monday, I'll drop you a link for a review, how to review, what's going to be on the test. I'll remind you of formulas to study. Remember, you have to memorize formulas. There will be no calculators, so make sure you can do all the calculations by hand, which is what you should have been doing all along. So hopefully you've been practicing all of your calculations and you don't need a calculator for any darn thing. The midterm will be 10 problems chosen from the most recent homework lessons. Again, I'll review that all for you in the video on Monday. If you are a student that lives locally, I will bring the test to your house, just like I've done in the past. If you are a student who found me on YouTube, if you would like a copy of the test, you may email me. My email address is in my About page on YouTube, or you can find me on Instagram or Facebook if you like, Twitter. You can reach out to me in any of those ways too, and I'd be glad to give you a copy of the test that you can take yourself. All right, enough procedural warm-ups. Let's get into the meat of our lesson. This is a lesson that comes from the body of math that we call statistics. All right, mathematics includes a lot more than just algebra. Not that algebra isn't important, but this is a branch called statistics. And this is just a taste. We're just dipping our toes in the water. We're not getting into it. But you may be in college and find yourself taking a statistics class, and that's what it is. It's mathematics where we're managing information in numbers and how to take a lot of pieces of information and draw conclusions about them. And that's what this lesson is all about. These are 4 different types of statistical calculations that we can make, and we're going to learn how to make them, and then we'll learn just a tiny bit about what they tell you. Now, if you're any kind of sports fan, you already know how important statistics can be, right? No matter what sport you're interested in, there are numbers that get tracked, either for an individual player or for a team or for ice dancers, complexity. No matter what the sport, there are always statistics involved. So that's another way that you may be familiar with this branch. Now, the most annoying thing about statistics is, in our world, copying down the data, right? Statistics always come from a number of results that we're bringing together and drawing some conclusions about. And it's annoying because we manage these data sets by hand. Now, that's incredibly artificial. In real life, this would all be done by computers. But let's look at the first example and you'll see what I mean. A freight company receives a shipment of 8 cats and 1 cow. I'm serious. That's what it says. 8 cats and 1 cow. Wouldn't you like to be in the boxcar where 8 cats and 1 cow were being shipped? I'm assuming there are no cages and it was just a free-for-all. It sounds fun to me. Their weights in pounds are, now I'm going to write them down and I want you to copy, which I know you do because you write down everything. You copy everything I write down, right? Okay, so cats. 1, 2, 3, 4, 5. You have to make sure I'm copying. There's so much repetition in the numbers. And look, here's the cow. Okay, so those are the weights of these animals. Obviously, these numbers are going to look weird, right? Because these guys are all really similar. And then there's that. Although I would have to say, cats that weigh 2, 3, and 4 pounds are pretty tiny. They must be little baby kittens. Because my cat, I have a pretty skinny cat, one of which is like 10 or 12 pounds. And then my bigger cat, his nickname is Chunky or Lunkard. He's not fat, he's just a bigger cat. He weighs closer to 20. So these are little cats, and I just need to talk about that for a minute. All right, now, the first thing we always do in these problems, step 1 is always organize the data. And what I mean by that is put it in order from least to greatest. So we're going to have to rewrite this list of 9 items, putting them in order. So let's see, 2 comes first. 1, 2, 3, 4 2s. Then we have 3 3s, a single 4, and then the cow. 1, 2, 3, 4, 5, 6, 7, 8, and the 800. Okay, so I made sure that I recounted. Now we don't need to look at this anymore. And P.S., in the future, what you can do is, this is written in the book, you don't have to copy it like that. Put it in order as you copy it. It's fine. Okay, so now we're going to go through and we're going to find these 4 measures. Let's start with the range. The range captures how broad the data, how broad of a dispersion is the real word, but I don't want to use it. The spread. So we take the high number and we subtract the low number. In our case, the high number is 800 and the low is 2. So this data set has a range of, 798. That's a 7. Okay, that's the correct answer. And that tells us something. That tells us that maybe compared to what the weight of another group of 8 animals, there's quite a bit of variation in this, isn't there? Okay, good to know. That's the first one. The next one is the median. And this is called the score. This is the fancy name for the score in the middle of the data set. Now, let's look at our data set. How many items do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're lucky because we have an odd number. And so we choose the exact middle. If there's 9 items, the number 5 is the exact middle, right? 1, 2, 3, 4, 5. And then there should be 4 on the other side. 1, 2, 3, 4, right? Because it's exactly in the middle. So in this case, ours would be 3. However, let's just pretend for a minute that we only had 8 items in our data set, an even number. So if it's an even number, we average the middle 2. Okay, so if this was our data set, we'd say, okay, 1, 2, 3, 4, so that's half of the middle, and then 1, 2, 3, 4, that's the other half. So we would see that our median is the average of those 2 numbers. It happens to be the same, so we would easily conclude that our median was 3, but these can be different numbers, and we'll see that in another problem. Okay, so the median is the score that's in the middle of the sequence. If you have an odd number of items, you'll be able to find the exact middle. And if you have an even number, you'll have to take an average of the middle 2. Okay, beautiful. Okay, I'm going to move on. You can probably still see this row of numbers. I'm not going to be showing it. You know what? I'm just going to copy it over. It's easier. Ready? These cats, can't you just see them jumping and screaming all over this boxcar? Okay, double checking to make sure I wrote it right. 3 3s, a 4, and an 800. Okay, good. The mode is the next one that we're talking about, the next of our statistical measures, and that means the most repeated. Okay, let me just look at one thing. Okay, So we review our data set and we say, okay, which of these numbers is repeated the most often? Well, let's see, we've got 3 3s, but we've got 4 4s. So or 4 2s rather, that's a 2. So in this case, our mode is 2. Sometimes we can have 2 modes, like say for example, again, say that's our data set, we would have 2 modes, 2 and 3, because we have 3 of both of them. Sometimes in a data set, if none of the numbers are repeated, we can have no mode. That's an option too. All right? So we'll always have a median, but we don't necessarily always have a mode. And the fourth statistical measure is called the mean. And this, the way I remember this one is it's very mean because this is just another name for the average. And you learned how to calculate averages probably a long time ago. So all we're doing is just calculating the average and calling it the mean. Fancy name. So here's what I'm going to do to add up the mean. We add them all up and we divide by the number of numbers, right? So I'm going to add this up. This is 2 plus 2 plus 2 plus 2. That's 8. And then I'm going to add 3 3s, which is 9. And then I'm going to put those two together and make it 804. Okay, so adding these is a pain, and like I said, in real life, no. We would just feed these numbers into a calculator or a simple computer, and it would calculate for us. 17, 21, and then we divide this by the number of numbers, 4, 5, 6, 7, 8, 9, we decided already. So then we just do long division, 821 divided by 9. Let's see, it goes in there 9 times. 81, and then it goes in there once, bring down to 0, put the decimal in, right, because we've got a decimal here, but we can keep adding zeros. It goes in twice, 18, now we subtract and get a 2. We see we're going to be doing this forever. That 2 is going to repeat. So the final answer that we could give for this is the average is 91.2, and we can put the repeating bar there, right? We don't have to go down one. And it's always nice when our problem has words to give words in our answers. All right, so there's how we calculate the average. Or the mean rather, it's just an average, okay? Range, median, and mode have new rules, but they're very easy to calculate. Mean is an old calculation that we're familiar with, but it's just more of a pain, right? Because we get decimals and icky things like that. So, all right, let's do another one. Let's practice these again. There are a total of 3 problems in this lesson, 3 examples. Okay, ready? Example 45.2. Did I even write 45.1? No, I didn't. I was so excited I just jumped right in. Let me write it here. 45.1. Okay, now we're on 2. The scores on the tests were blah, 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 a whole bunch of them. Find the range, median, mode, and mean. Okay, so John writes them out of order. So again, our first task is to arrange them in order. I'm going to give them to you in order as a gift. Consider it early Christmas, late Hanukkah. So instead of being able to write them all in one line, I'm going to just write them to you this way. Write them to you? I mean, I guess, right? 95. Okay, so there are 8 elements ranging from lowest to highest. So first one, range. That is, we take the highest, 95, and we subtract the lowest, 60, that calculates a range of 35. Yay. Okay? That's not 35 percentage points. These are all scores on a test, right? 35 just represents the number of points between the highest and the lowest. Okay, median. Just like a median on the expressway is that concrete barrier or the grassy part, sometimes the median is grassy, it's the middle, it's the in-between. So we count our number, 1, 2, 3, 4, 5, 6, 7, 8. That's an even number. That means we won't be able to find the exact middle. So we're going to average the two that are closest to the middle. So let's see, there's 4, and then we count 4 backwards. Yeah, so it's going to be 83 plus 85 divided by 2. And I don't even have to do the math on that. I can see really quickly that the median is going to be 84. Okay? That tells us that half of the kids got better than 84, half of the kids got worse than 84. Okay. Mode. Which score was repeated the most? And as we look at this, we go, oh, there's no repetition at all. So in this one, we say no mode. You can have one mode, you can have 2 or more modes, or you can have no mode. Huh. Mode's kind of temperamental. And then the last one is the mean. And this is where we have to calculate the average, right? So I'm going to give you a gift, and I'm going to tell you that all of these add up to 646. If you were doing this problem without me, you'd be sad, I know. But what you would have to do is lift those all out and add them up by hand, and then we're going to divide them by the number of numbers, and that is 8. All right, now we shall do the long division, and that is 8 into 646. Ooh, 8 into 64, that works out perfectly. 8 times 8 is 64, right? We subtract, we get a 6. It means we need to put a 0 here because 8 doesn't go into 6, but we'll decimal and then we'll bring down a 0. 8 times 7 is 56. Subtract, get a 4, bring down another 0. 8 into 40 is 5. Oh, look, I'm going to squeeze it in. You can't see it. But our mean is 80.75. Okay, that's the correct answer. This tells us the score that half got better than, half got less than, but this is kind of a more nuanced number because it takes into account the extreme ends. Median only measures what's in the very middle. This kind of lumps everybody together and tells us something about the group as a whole. We're not going to spend much time interpreting these different scores. That is exactly what you would learn in the statistics class. We're just learning the basics of how to calculate them. And we're learning a little bit about what they represent, right? But we're not going to do a big analysis. Okay, one more. 45.3. The mean, okay, this one's a little different. The mean of 5 numbers is 10. Okay, so we have 5 numbers. And the mean equals 10. 4 are the numbers, are 2, 8, 11, and 14. Find the 5th number. All right, we have done this kind of problem before, and it's a little bit tricky, so I'm going to remind you of how to do it. I do these completely differently than John. I don't like how he does them. I think it's confusing. Okay, let's pretend that we had all 5 numbers. Let's just put an X here. That's our mystery number. Now, what did we do with them when we calculated the mean? We added them all up. We got a total here. And then we divided by the number of numbers, didn't we? 1, 2, 3, 4, 5. And when we did that, we got the mean, which is 10, right? That's where we get that 10. This is how we know there are 5 numbers here. This is how we know to divide by 5, because John said there were 5 numbers. We filled in the blank there, and then we divided by 5 because that's how many numbers we're told we had. And we know that the answer to that problem was 10. Now, this is the normal way to do this problem, right? Assuming you can do that division in your head. Normally we'd have to do some long division, but we're going to pretend. What we're going to do in this particular problem is we're going to work backwards. So if our answer was 10 when we divided some big number by 5, we can multiply 10 times 5. We know this number had to be 50 because 50 divided by 5 equals 10, right? So that's how we know that has to be right. We work backwards, like so, right? 10 times 5 equals 50. That's how we came up with this. Now, we can add together these four numbers and see how much they add up to. There's 10, 21, 35. This much equals 35. 35 plus this number has to equal 50. So this number is 50 minus 35, or x equals 15. Make sense? We set up the calculation the way we knew it went, even though there are holes that we can't quite figure out yet. Then we work backwards. The mean times the number of numbers gives us the total, and then we add up the ones we do know and subtract them from the total, and that gives us the one we don't know. This is so hard to remember and to wrap your head around. Students struggle with this. That's why I teach it differently than John. I think if you can take what you know and lay it out in a logical way and then learn to work backwards, your brain can absorb this. But I've seen students handle much more complex material, but just pull their hair out when they get to these average problems. So please trust me, do it like this and it will help you. Yay, guess what? 45 is done. You've now been introduced to statistics. We're gonna see this year after year. It just comes back and it never really gets harder, but John just keeps reviewing these so that you'll have a little splash of an idea of what they're all about. Okay, guess what? 45 is over. I will see you next time. Goodbye.